Before we dive into the shape of bonds, first let me introduce to you the VSEPR theory. It states that electrons repel each other, therefore a compound will form a shape where the total repulsion of electrons is the smallest. Take carbon dioxide as an example. There are two molecules that bond to the central carbon atom. Since the bonds want to be as far away from each other as possible, the two bonds lie at the two sides of the carbon opposite to each other. Therefore, they form an 180-degree angle. In chemistry, this is called a linear bond. The next compound we are looking at is boron trifluoride. The bonds in the compound are also stretching as far away from other bonds as possible. Reasonably, the compound looks trisected, forming an 120-degree angle. Unlike what some may think, a compound with 4 atoms binding to the center molecule does not form a 90-degree angle. The methane forms a tetrahedron shape. In contrast to the first two shapes, the tetrahedral shape is 3-dimensional, with a uniform angle of 109.5 degrees. Phosphorus pentafluoride consists of 2 parts. Vertically, there are 2 orbits that form a straight line. Horizontally, the rest 3 orbits splits the plane into 3 parts. This is a trigonal bipyramidal shape, and it has 2 different angles. The angles between the vertical bonds and horizontal bonds are 90 degrees, while the angles between the horizontal bonds are 120 degrees. Sulfur hexafluoride has a similar shape to the previous compound, but instead of having a horizontal trigonal plane, the horizontal bonds quarters the plane. This makes the angles between the horizontal bonds also 90 degrees. This is an octahedral shape. There are also some special compounds that are different to the ones listed above. Water, as shown, does not follow the linear shape that we have just mentioned. This is because oxygen has a lone pair of electrons, and these electrons also exert a repulsive force. Consequently, water has an angle of 104.5 degrees, which gives it a non-linear shape. Similar to water, the nitrogen atom in ammonia also has a pair of lone electrons, so it forms a pyramidal shape, with a 107-degree angle between the bonds. In summary, the first 5 shapes mentioned only occur in molecules with central atoms without lone pairs of electrons. All of these shapes has a uniform angle. The last 2 shapes form only within molecules with lone pairs of electrons, and the angle also varies depending on different compounds. Next, we are going to take a look at the shape of orbitals after they form bonds. There are 2 types of bonds orbitals can form. First is a sigma bond. This bond forms when the orbitals overlap directly, which is equivalent to linearly. The electron density in sigma bonds are symmetrical. Here are 2 examples of sigma bonds. Also, it is possible for orbits of different shells to form sigma bonds. We'll talk about that shortly. The second type of bond is pi bonds. These bonds form only between p shell orbitals, and it occurs when the orbitals overlap horizontally. In this case, the electron density is asymmetrical. Next, we will focus on hybridization, which is the process of mixing 2 different orbitals to make a new hybridized orbital. The first type of hybridized orbital we will look at is sp orbital. It combines one s and one p orbital to form 2 new orbitals. As you can predict, it has 50% of s orbital traits and 50% of p orbital traits. Here is a diagram of the product. 2 of these sp orbitals combine, forming a linear shape. Examples of sp molecules include all compounds of beryllium and all carbon compounds with triple bonds. sp2 orbitals inherit 33% and 66% of s and p orbital traits. The 3 sp2 bonds form a trigonal planar shape. Examples of sp2 molecules include all boron compounds, all carbon compounds with double bonds. sp3 orbitals contain 25% of s orbital traits and 75% of p orbital traits. The 4 hybrid orbitals form a tetrahedral shape. Ethane and methane are all examples that contain sp3 orbitals. This is all for this video. Thank you for watching and remember to subscribe for more A-Level chemistry videos.